Hello, I'm Nishant. Welcome to the Fast Learning series for CAT. This is the seventh video in this series, and today again we have a set which is a mixture of DI and LR. So let's see the set. There are 11 players on each side in ODI cricket, and one team bats while the others bowl. Then the teams swap after 50 overs. With an eye on the 2019 World Cup, the coach of Indian ODI cricket team, Ravi Shastri, is a master strategist who thinks faster than a tracer bullet when it comes to shuffling the batting order. In a recent match against Australia, India scored 340 runs for the loss of 9 wickets, and the last unbeaten pair of batsmen together scored 40 runs before they ran out of overs. And we are given some 9 clues to solve this puzzle. So let's have a look at the questions. Now I want you to pause this video here and try to genuinely solve this question, because in the next slide I am going to discuss entry point of this set, and I want you to see the power of that entry point, because when you have that entry point right, then it's a cakewalk, and if you don't have it, then it's very annoying and you can't even solve a single question. So please try to solve this set here. Now let's resume. A general rule of thumb says that entry point of a numerical LR set lies in the implicit information. So while all the information is given explicitly, there is one information which is implicit. That is, the run scored by any player is an integer. Since the first two batsmen scored 50 together, and we know that the ratio of first three batsmen scores is 6 is to 4 is to 3 in no particular order. So let's say that the ratio of first two batsmen is 4 is to 3 or 3 is to 4. In both the cases, the equation is 4x plus 3x equal to 50. And clearly this will not give you an integral value for x, 4x or 3x. Similarly, the ratio cannot be 6 is to 3. So the hidden information was that the ratio of first two batsmen must be 6 is to 4 or 4 is to 6. This means that the first two batsmen scored 20 and 30, and the third batsman scored 15. Now, in this table, you will see that the first point is already represented, which says that the fourth and the fifth man each scored 100 runs, while the first two batsmen scored 50 between themselves. This also represents the information given in the second point, which says that the ratio of runs scored by the first three batsmen, Shikhar, Rohit, and Hardik, though not necessarily in 1, 2, 3 in the batting order, was 6 is to 4 is to 3. This point clearly means that Shikhar is scoring the highest, that is 30, and Rohit is scoring 20, and Hardik gets 50. Now, let's focus on the fourth point. It is a very straightaway information. It says Dhoni was the eighth batsman, and the batsman coming after Dhoni scored a 5. So, we'll represent this information in our table, and now we'll focus on the sixth point. It says Rohit scored 1/5 of the Manish score and equal to Virat's score. We know that Rohit is scoring 20. This means Manish is scoring 100 and he is either the fourth batsman or the fifth batsman. The other information is that Virat is scoring 20. We cannot represent this information in the table because we don't know the position of Virat. So we'll just mention it as a bullet point. Next, we'll focus on the point number 7, which says Kedar scored 5 times what Virat scored. So Virat scored 20, Kedar scores 100. This means Kedar is either the fourth batsman or the fifth batsman. So one thing you will notice is the things which are not sure are followed by a question mark in the table. For example, Manish can either go in the fourth place or in the fifth place. Therefore, Manish and Kedar both have a question mark at the end. But we know that the fourth and the fifth batsman both are scoring hundreds. So hundreds are not followed by a question mark. Now let's move on to the next point. It says Bhuvaneshwar and Jasprit scored 18 and 22 respectively. So clearly Bhuvaneshwar and Jasprit are the last pair of batsmen because the third point says that two consecutive batsmen scored zero, and the first nine batsmen in the batting order scored either zero or scores that were a multiple of five. So clearly 18 and 22 are not zero, and they are not a multiple of five, so they are the 10th and the 11th scores. So Bhuvaneshwar and Jasprit will go in 10th and the 11th spot. Now the other information is that they scored 25 more runs than Dhoni and Hardik together. So let the score of Dhoni be X. Then 15 plus X plus 25 is equal to 18 plus 22. This means X is equal to 0 and Dhoni scores 0. And we know that the third point says two consecutive batsmen scored 0. So the batsman just before Dhoni must also score 0. Now there is only one place left for Virat, so Virat will go there. The ninth point says Yuzvendra was India's most successful bowler of the match, and Kuldeep took 2 wickets less than Yuzvendra. The interesting thing is that this point is not given to tell us the bowling figures. It is there to tell us the names of those two batsmen in those two empty cells. So now let's focus on the fifth point, which says the runs scored by Virat, if added to the extras, equaled Sikhar's score. So Virat scores 20, 20 plus x equal to 30, so x is equal to 10. Extras are 10. Now we have solved the entire table almost. We have used all the clues. Let's go to the questions. The first question is, what was the number of extras in the Indian score? The answer is clearly 10. The second question is, Virat's number in batting order was immediately after whom? So Manish or Kedar? So the correct answer is C. Third question is, what is the total of the least 5 scores in the Indian cricket team excluding extras? So the correct answer will be 0, 0, 5, 15 and 18. So the sum is 38. The fourth question is, who has scored 5 runs? So we are not clear if Yuzvendra or Kuldeep has scored 5 runs. So the correct answer is D. Now let's move on to the key takeaways. So we have seen in the first two videos of this series that the entry point of a numerical LR set lies in a constraint, hidden constraint, for example in maxima or minima. So this is another common type of constraint that a solution has to be integral. This was the first key takeaway. Now the second key takeaway is sometimes even in a non-entry point way, this trick comes handy. We will see it in action in future videos. Hope you like this one. Bye.